You guys can turn on your cameras. Okay, so today's question. Particulate representation or diagram. This is a very important question. Like it's always gonna be there in any AP test. They're always gonna ask you to go and draw something. And the drawing is like easy points to score because sometimes one drawing will have 4 points on it. Okay, so we need to learn how to draw it properly. So when they're gonna give you a box, which in this question did not give you, but it said they gave you a box. Oops. Just gonna draw a box like that. Okay. Now, they say that draw a particular representation of the species present in the beaker after complete dissolution. When BeCl2, beryllium chloride, are dissolved in water, what's gonna happen? What's gonna happen, someone? When it's dissolved in water, what's gonna happen? Ahana? Yeah. Joey.
Hello?
Yeah. What's gonna happen when beryllium chloride dissolve in water? What's gonna happen?
Wait, I just got here. Can I look at the question?
Oh, yeah.
I just joined, sorry.
That's okay. Anyone? What's gonna happen when you add ionic salt or ionic salt into water? What's gonna happen? If they're soluble salt, they're going to dissociate. Okay, they're going to dissociate into ions. Ionic salt, when mixed with water, they're going to dissociate into ions. Okay, they're going to dissociate into ions. So we have what? Beryllium chloride, BeCl2. What are the ions of BeCl2? Ava,
Sorry, what was the question?
what are the ions of BeCl2?
Beryllium 2 plus and chlorine -1.
Okay, and chloride, right? -1, good. Okay, now, how would you, okay, of course you're gonna have 2 chloride, right? You're gonna have 2 chloride. Now, how do you guys draw this? How do you guys draw this? You're gonna do 1 Be, right? You're gonna draw 1 Be2 plus and 2 Cl. If I draw it like this, is this correct? I want someone to tell me what mistake I made.
The size.
Good. The size. What about the size?
The beryllium ion should be larger.
Beryllium ion should be larger.
And the chlorine one should be smaller.
Is that correct?
Shouldn't the beryllium be smaller and the chlorine be
Yeah,
larger?
shouldn't it be flipped?
Oh, yeah.
Why? Okay, let's see. Periodic trend. Why does beryllium needs to be smaller than chlorine?
Since it loses electrons, or since the chlorine gains or since the chlorine loses.
So,
since
okay, let's see. So you guys are saying which one should be larger, calcium or fluorine? Anyone? You guys participate. Which one is larger, calcium or fluorine? I mean, like calcium ion or fluoride? And reasoning as well.
Is it calcium is larger because I think I remember that the closer you are to having one valence electron, the larger your shallows are since they're more like far apart. And fluorine is the closer you are to fluorine, the smaller you are.
No. Anyone else? That's okay. Gonna go. Good try though. Anyone else want to try?
Is it calcium because they have more like like more shells for their electrons?
There's more shells. Okay. So, okay. I'm just gonna open the periodic table. See the size. We're gonna learn the proper way though in our like full program. Okay, the proper way. We're gonna start with unit 1, which include the periodic trend. But right now, I'm just gonna give you guys a little bit introduction to the periodic trend. So, as you go, okay. What are these known as? What are these known as? Groups. Okay. What does the group signify? When you have the same group, you have the same what?
Characteristics.
And?
Valence?
What? I think I hear it. What?
Valence electron, like
Valence electron, yes. That's why you have the same charge, right? Because valence electrons, they're gonna go away the same amount, so charge would be the same. Okay, so you in the same group, you're gonna have same characteristic, same valence electron, same charge. What about this? What are these known as?
Periods?
Okay. What are the similarity all elements have in the same period? No one? They have the same the number of shells. They have the same number of shells, okay? So for example, if I would draw between lithium and sodium, okay? Let me draw the Bohr structure. So lithium has, what's that, 3 and 11. Lithium has 3 proton, right? 3 proton. I'm just going to write 3p. And then look at which period it is. Second period. That means it's going to have 2 shell. Okay? So let's say the first shell has 2 electrons, the second has 1. Sodium, 11 proton, 11 electrons. It has what? It's on the third period. It has 3 shell. 8, and 1. So guess what? As you go down the group, you are increasing the number of shell. Okay? You are increasing the number of shell as you go down the group. As you increase the number of shell, what's going to happen? The size will become bigger. Okay? As you go down, the number of shell going to increase and the size will become bigger. So when we look at the beryllium and chloride, right? What was it? Beryllium and chloride, right? How do you, okay, and it's what? It's ions. Okay, beryllium and chloride, both of them are ions. So let's draw the electronic configuration. Go ahead, write it down, the electronic configuration. Before you write down the electronic configuration of Be2+, write for the Be and write for the Cl. And then you write down the electronic configuration for the Be2+ and Cl-. Okay, you guys know how to write the electronic configuration, right? The 1s2, 2s2, blah, blah, blah. Do that first, okay? Write down the configuration for Be and Cl. And plus means what? You lose electrons, so you're going to take away from the outermost shell or outermost orbitals. And then, yeah, write it down, everyone. Now I'm going to ask you. Okay, someone help me with Be. Just the Be configuration, please.
Is it 1s squared, 2s squared?
We call it 1s2, 2s2, okay?
Okay.
And the Cl? Anyone else? The Cl, okay, not Cl minus. Cl?
Cl is 1s2, 2s2, 2p6, 3s2, and then 3p5.
3p5. Okay, good. Now, when even with drawing the configuration, you already know, okay, Be has 2 shell, right? Cl has 3 shell. Okay, that's pretty large. Cl is larger than Be. Now, we're gonna do the ions. When you have 2 plus, what does it mean? When you have 2 plus, it means, means you lose 2 electrons. Okay, so where are we going to remove the electrons from? The outermost shell. So we're going to remove the 2 from here. So Be2 plus is actually just 1s2. So what does it mean? It means that Be2 plus only has 1 shell. Okay, Be2 plus only has 1 shell. Minus means what now? Minus means what?
You gain an electron.
An electron.
To where? To where?
The outermost shell.
Which is the?
Uh,
the
3p5.
3p. So we're gonna do 1s2, 2s2, 2p6, 3s2, 3p6. So as we can see, Be only has 1 shell and Cl minus has 3 shells. So that's pretty large when we compare Be and Cl minus, right? Now I want you guys to try, what was the previous question I gave? Calcium 2 plus versus F minus. Go ahead. Right now, just do the long way, okay? I know most of you are smart. You can do it in your brain, but just do the long way for now, okay? Write the configuration of the ions. I mean, like, you can either do this and directly from here, you can get the configuration of the ions and then compare them and the reasoning. And also I want someone to, I want all of you to get ready. Which is the bigger ion and why? Which is the bigger ion and why? Reasoning 2 points. Okay, first you have to tell which is the bigger ion. Second, you have to explain why. Get ready with all the explanations so you can just read it to me. Okay, I'm just gonna call anyone. Oh, maybe you guys what? You can text me your answer. You can put it in the chat box personally, okay, not where everyone can see. Click on the new chat, click my name, and just text me. Which is the bigger ion and why? Start with the configuration, guys. Start with the configuration. Start with the configuration. I need everyone to text me, okay, your answer. There are 11s of you. I need 11 answer. We're talking about Ca2 plus ion and F minus. Pranit, you have to do the noble gas configuration or the full configuration. You cannot just write the valence configuration.
Okay.
You see what you missed, right?
Yeah, I remember.
Okay. Round 1, it's F minus fluoride, not Be. Calcium ion versus fluoride. Okay. Now, Pranit, make sure to have your which one is bigger and why. I can see a lot of you have confusion in this topic. So we're not going to do whatever the worksheet. We're going to talk about this today, okay?
I have one question.
Mm-hmm.
When you're referring to which one's bigger, would you refer to Ca and F, or would you have
No,
Ca2
this
or F?
Ca2 plus versus F minus.
Okay.
Okay. Now, I've seen all of your whoever sent me the answer. I would say only one or two of you going to get the full points. Okay, first, some of you already had the wrong answer. Second, the reason is not correct. Okay, AP chemistry, especially the FRQ, they're very particular. They're very strict about the points, especially the reasoning point. Okay, first of all, how would you answer this question? Which is bigger? When we talk about size, okay, when we talk about size, we only care, first, you want to compare their, please write down this. When we talk about size or any periodic trend, as a matter of fact, okay, you want to compare the number of shell first. Okay, you want to compare the number of shell first. If they have the same number, of course, the more shell, the bigger it is. If they have the same number of shell, then you go to the next one, which is the proton. If they have the same number of shell. If they do not have the same number of shell, the one with the higher shell gonna be bigger, that's it. If they have the same number of shell, the next one you want to compare is the proton. Okay? Okay. First, you compare the number of shell. The more the shell, the bigger is the size. Simple, that's the reasoning. And you're done. Okay? The second one, the number of proton. If the shell is the same, next you compare the number of proton. Where does the proton located?
In the center, like the nucleus of the
In the
atom.
nucleus. Okay. Now, what does the proton do? What does the nucleus do? The nucleus gonna have a nucleus has what charge?
Positive.
Positive. Yeah, I want different voices to answer, okay? So if you feel like you haven't been answering, just answer, okay? Okay, so the nucleus gonna have positive. When you have higher number of proton, your positive gonna be so strong. Okay, if you have the same number of shell, okay, if you have the same number of shell, let's say one shell each, and this one has one proton, this one has two proton. We're talking about hydrogen and helium. Whose nucleus is stronger? The one proton or the two proton? Answer, guys. Yeah, Salma?
The 2 protons.
The two proton. The two proton gonna be stronger. The nucleus of two proton gonna be stronger. Then what they're gonna do? They're gonna go and pull, attract the shell with the electrons in, right? Because the electrons is negative, positive, negative, attract. So the two proton one is going to attract more. So what does it tell you? When you have higher number of proton, is the size gonna be bigger or smaller? Yeah. If you have higher number of proton, your nucleus is gonna be stronger, right? Your nucleus is gonna be stronger. And you're gonna pull the what? The shell inside. So the size is gonna become what?
Smaller.
It will become smaller. So size reduce. Higher number of shell, the size or radius gonna increase. Okay? And the third, let's say the number of proton here also the same. Now to break the tie, you then look at the number of electron. When you have high number of electrons, they're going to be what? Repulsion. More repulsion. If there's more repulsion around the shell, what's gonna happen? It's gonna become bigger. Say, no, you go away. No, you go away. So it will become bigger. Okay? So high number of electron, higher the size. So far makes sense? We're gonna see some examples here, okay? Don't worry. So let's say we want to compare between fluorine and nitrogen. Okay? Now, we go back to this. We go back to this. Make sure you all of you write down this, okay? Very, very important. So, what was the question? Fluorine and nitrogen, right? First, what do you see? The number of shell. First, what you see? The number of shell. So, fluorine and nitrogen, do they have the same number of shell or different number of shell?
Same number of shells.
Same number of shells. So then what do we do? This one is not applicable, right? Because they're the same. Then what do? We look at the
number of protons.
number of protons. Okay, so between fluorine and nitrogen, which one has more proton?
Fluorine.
Fluorine. So who's gonna be bigger?
Nitrogen.
Nitrogen, because more proton means it's going to attract. When it's attract, the size is gonna become smaller. Okay? So, going back to the question, how would you answer this? Calcium versus fluorine. First, what do we look at? Number of shell. So, you guys did do the configuration, right? Most of you did it correctly. Yeah. So 1s2, 2s2, 2p6, 1s2, 3s2, 3p6. And then for fluorine, 1s2, 2s2, 2p6. Now, once you cannot just leave your reasoning be the oh, this is the configuration, that's why it's bigger. No, you're not gonna get the point for the reasoning. You have to explain why. First, if you write down you can even not write down the configuration, that is still fine, but you have to explain. So you want to say that calcium 2 plus has 3 shells, or do you guys know what's the fancy word of shell? No? Principal energy level. Okay? I mean, like, if you want to sound fancy, you can use principal energy level. It doesn't matter. You can use shell as well. Okay, so calcium has 3 principal energy level compared to fluoride, which only has 2. That's why calcium is bigger than fluorine. That's it. Fluoride. That's it. Okay, simple as that. You can either, but you have to be specific though. You can either say calcium has 1 more energy level compared to fluoride, or you can be specific as you said, oh, calcium has 3 energy level and fluorine only has 2. That's why calcium 2 plus is bigger than fluoride. Okay? Now let's try another one. I need you guys to tell me which is bigger and the reasoning why, okay? Mg2 plus and Na plus. Which is bigger and why? With the reasoning, feel like, oh, think like you are in an AP test and you're trying to show off your reasoning. Rawan, a proper sentence. I said like AP test, right? Diksha, you have to follow the chart. What do you first look at? You don't just like pick whatever you want. You start with shell. If that's the same, you go to the number of proton. If that's the same, then you go to the number of electrons. Okay? You have to do one by one. Oh, okay. Okay, good job, Rawan. Gia, you just made the perfect answer. Very good, Pranit. Very, very good. Yeah, that's really good. Very good, Bhargav. Okay, good. Hi. Good job, Ahana. You guys get it. Good job. Okay, so how how does a perfect answer look like? First, you need to be able to recognize that both of them have the same electronic configuration. You don't have to say, oh, they both have same electronic configuration. You can say that both of them has the same number of electrons. When two elements or two ions have the same number of electrons, what do we call them? Anyone know? Iso? Does anyone know? What do we call them?
Isotopes.
So electric.
Isotope? No, isotope's different. Iso
Isoelectric.
electron. Yeah, isoelectric element. Okay. So both of them has the same number of electrons, so they are known as isoelectric ions. Okay. Now, because you have to mention that, okay, they have the same number of electrons. And then what do you have to say? And they also have the same number of shell, right? And then once you say they have the same number of shell, you can say what? But magnesium has more proton compared to sodium, right? Mg2 plus has more proton. See, some students, that when you do not learn the correct way, that's why your reasoning, you don't get, even though you feel like, oh, I know everything in AP Chem, you still do not get a 4 or 5 or even 5. Why? Because your reasoning is wrong. Some student, they would think, oh, because there is 2 plus charge. This is like what 50% would say. The reason it's smaller is because it has 2 plus charge. But no, I want to teach you guys the right way. Okay? So because it has more number of proton, it's what the nucleus is going to attract or pull the shell more closely and cause the size or the radius of the ion to be smaller. Therefore, Na plus is bigger than Mg2 plus. Okay? Okay, let's try another one. Um, Give me a moment. Wait, actually, let's see. Okay, go ahead. Try it. I do want you guys to do the configuration for this though. This is interesting. Oh, okay. Fe3 plus versus Fe2 plus, okay? And this is the chart. Anyone need explanation again on this chart? I need the configuration, guys. Fe3 plus and Fe2 plus. Yeah, it's not a part of the reasoning and the thing, but I need the configuration. Okay, write down the configuration first before you start your answer. Almost there, Joey. Not quite though. I really like that most of you know the configuration because some do get confused with this configuration. There you go. I see it already. The confusion. Okay. So Fe, what is the configuration of Fe? If we just like write down the noble gas configuration you have for Fe, okay? You have argon, and then you have 4s2, 3d. What's that? 1, 2, 3, 4, 5, 6, 3d6. Now, when we, okay, let's say we want to do Fe2 plus, right? Where do we take the electrons from? do we take from the 3D or 4s, and why?
We take it from the 4s because it's the outermost shell. You take from whichever one is the outmost.
Good. We take from the outermost first. So when we want to remove the 2 electrons, we're going to take out from the 4s. Okay? So for Fe2 plus, you're going to get argon 3d6. And for Fe3 plus, you're going to have, now you're going to take 2 from here, 1 from here. You're going to have argon 3d5. Okay, good job on the configuration. Anyone still not understand the configuration? Configuration's fine. You take out from the outermost first, okay? Even though when we say outermost, why? The fourth shell is outer to the third shell, right? That's why outermost, not in their sequence. Okay, now this sequence is based on what? Why do we usually write 4s before 3D? Why? Let's see who can answer this. Why do we write 4s before 3D? Yeah, someone?
Is it because it shows up first on the periodic table?
Why does it show up first in the periodic table? Remember, there are three rules of how to put in your electrons in electronic configuration. Aufbau. What was Aufbau rule? Because this sequence is based on their energy. Okay, based on their energy. 3D has more energy compared to 4s. That's why 3D comes later than 4s. Okay, it is when we put in electron, we put in based on the energy. But when we take out based on which one is farther away from the nucleus. Okay, anyway, now which one is bigger? So first, what do we see? We look at the number of shell. So Fe2 plus has 3 shell. Fe3 plus also 3 shell. So number of shell is fine, right? Shell is fine. Now we go to the number of proton. Because both of them are Fe, right? So number of proton is the number of atomic number, 26. So both of them has the same number of proton, which is 26. Now where do we go? Number of electrons, right? Now, you guys got into here, but you did not reason why the one with the more electrons, which is Fe2 plus, is bigger. Why the one with more electron is bigger? Because there is more electrons did a bigger ion because there is more what? R, starting from R. What is that? There is more?
Repulsion?
Yeah, repulsion. Okay? When electron repulse on their shell, what's gonna happen? The ion gonna become bigger, or the atom's gonna become bigger. Okay, so you have to talk about the electronic repulsion in your answer. Okay? Not just because it has more electrons, but what happened then if it has more electrons? There is more repulsion. What happened if there is more proton? There's more attraction to the nucleus. Okay, you have to explain that part. Okay, well, we did not go over whatever we should have been going. That's okay. I hope this makes sense though. Okay. Well, this is just the size and this is just the trend for the size. But if you follow this chart, you can answer the electronegativity, the size, electron affinity, ionization energy, all of those can be answered based on this. Okay. Any question? Okay, good job, Bhargav. Any question? Okay, I'll see you guys tomorrow then, okay? Make sure to attend. These are like free lessons, so I don't know why no one, like anyone will not attend. So yeah. Bye-bye.